Yes, again another episode on CAM training guide. Just to learn a simplified. My episode is just to bring basic training. We do a recap. We did in relation to the fundamental machine mastery, key areas that you need to understand for you to do programming, like what we had already presented previously on understanding the coding system, understanding the axis and also the units used, whether millimeter or inches, understanding the cutting parameters, the depth of cut, the speed of speed, the cutting parameters, or the cutting speed. So each one of them is very important, so that when you are programming, you're able to rely with what is required for that work. Because at the end of the day, it's the work that the client wants to see and how quality it is. Then we have to explain various parameters for threading, which G-code are used in threading, and their format, also structure. If you look at our previous session, we already explained all this. We went ahead to explain on grooving, some of the codes you can use for grooving and cutting off, like G74, G5, its format and also the structure and the type of grooving you can use. We went ahead to explain some of the conversion, maybe from pitch to TPI. You're using pitch to TPI, and then we give an example of codes you can create if either you're using G76 or you're using G74 or G75 for each one of them. And then we also explain various ways of now converting a program. If you are conversant with ISO program, but you are now using the Siemens controller, how can you maneuver to create a program in Siemens controller Siemens 8 or HD? And I said you initialize using G291, then you start your program with G291, then you now create the program as you wish in Siemens controllers like Siemens 808. And also explain the history or some of the controllers that are there, like 802, 808, 810, 828, 840, DSL, and Siemens 1, and also the timeline in terms of the evolution. We went ahead also to explain the various terminologies you can encounter as a machinist that are used in threading, like UNC, UNF, and also UNP or pitch, or a formula that you need to use when you calculate some of this. And also give a table, master table for each one of them, so you can refer when you're designing and also when you're doing machining. So today we want to look at some of the CAM operations, just as a training guide for CAM, how you're able to understand the CNC turning, CNC milling operations, tool approach, and also CAM software that are used in various operations. We can go direct to turning operations. I just do an overview of what each one of them may mean, like we were doing facing. I'll show you the video of what we've been doing, this information for each one of them so that you understand practically what it means by facing. So facing, just flattening the end of the raw bar or workpiece to create a smooth reference surface. Normally it is applied to prepare the zero level or removing the extra material on the surface so that you create a perpendicular data. Normally the tool approach, if when you're doing CNC turning for this, you normally approach from X positive and then you move towards the center line. Either you can exit it to a certain point, or you can do maybe to various maybe to the core center line. So that you can also use various tools like maybe NMG, DNMG, VCT, depending on the tool. But normally VCT is not good for facing. You need to use either SNMG, TNMG, WNMG, or DNMG for facing. Also, we have another operation called straight turning. Normally, most of the machine call them OD, outside diameter turning. So in this outside diameter turning, it means you're reducing the external diameter along the z-axis. So normally they are applied in making shafts or stepper shaft that you're using gear, maybe gears or gearbox. You can use to create pistons, you can use to create bushings and other parameters. The tool approach is very important. This one you will have to check on the tool nose radius compensation, then how you're going to approach from one point to another. When you say roughing, you are cutting it with maybe with a huge depth, so that you use material first before you do cleaning to give you the final workpiece. We also have to call shoulder turning. Shoulder turning is like you're doing step turning. Let's say angle, maybe it can be 90-degree step turning or angle steps. We can also call it taper turning. Normally they are applied to making step shafts, which are used in the gear in gearbox. You can create maybe gear sets, or you can create what you call bearing shoulders. The approach also depends on the tool, or you can either move from X using you can feed to X and then move to Z, or feed Z then move to X. Either using what you call turning along X or turning along Z, depending on how you are going to approach. Then you have what you call contour turning or profile turning. This one normally are used to make what you call complex shapes that are maybe curved or have angles. They say maybe concave shape or convex shape. So they are normally used to create what you call contour turning. Application is good. Maybe you are making the bottleneck for blow or injection mold. You are doing decoration of parts, or you are creating complex shapes that have these features like the knob, the crankshaft, connecting rod that has at the end of it has different shapes for the purpose of ensuring that you achieve the output. The tool approach may depend on the tool you're using and also the orientation of your machine. So this one I may not say that you need to approach from this side. Then you have another operation called grooving. Grooving, you are making a narrow slot on either the outside diameter or on their face. The main application normally is to put O-rings for preventing leakage, or they normally call them seals. You can either put O-rings or seals to prevent the snapping, to prevent leakage, or also applying what you call snapping or retaining features. Approach may depend on the tool, also may depend on how you are going to plunge into material, either from side or from the top to the bottom. Then you have another operation called parting or cut off. This when you say parting or cut off, you are separating now the finished work from the bar stock. Normally this one is done at the last option when you have done all other operations. It's applied in production, normally production, when you want to now do mass production. You can now do what you call parting off. The tool approach may depend. Normally maybe you can move from X and then you can fit Z, then move X, then from there you are able to fit the material, then you cut using G01, or they require the code for a part off. Then you also have another operation called threading. Threading normally are used to create either external or internal threads. They may have different shapes, either for maybe taper or straight threading, or even face threading. So it depends. This one normally I applied in making bolts, making nuts, making pipe fittings like NPT, and also making machine components that are used in industries. The angle, some of the angle you can use angle like 60 degree or 55 degree. If you are making metric systems like metric systems, UNC and UNF, you can use angle 60 degree. But if you are making it for woodwork shapes, you can use angle 55. But if you making for UN ISO, you can use angle 29. So as the infill. And then the cycle may be either G76, G32, or G3, or even G92, G82, depending on the machine. But for cement, they normally use cycle 97. You can also do boring. Boring, it means you are enlarging already existing hole. If you say drilling, you are making a virgin hole. But you are saying boring, you are enlarging already existing hole, or you are enlarging a virgin hole, so that you create a part either for creating bushes or housing or even cylinders. This one is very important. The tool may approach from the Z, then it goes feed X, then from there to the body. Then second last operation, you have what you call drilling. Drilling, as I said, these are now you're creating a virgin hole or a new hole into a workpiece. And normally for turning, you approach through Z, and normally used either to make center holes or through holes or blind holes. And then we have another operation which is very important called tapping. Tapping is just this is now internal. You can use it either for normally for use for internal. Let's not normally say otherwise. It's normally used for internal ID threading, internal threading, where you can do it either manually or you can use a machine. This one is allowed to create internal threads using a tap. They can use to make maybe nut threads or threaded holes. The application is normally very important depending if you are going to depending on the purpose. Let me say depending on the purpose. Then last operation normally that people normally on CNC machines, some of them don't do knurling, they do it manually. So knurling is just in printing a pattern on the either the OD or in. So normally they don't do it on OD. OD means outside diameter or face, so that it allows for grip surface, to create a grip surface. Others can do it for decoration purposes or can create it for as tool handles. So these are some of the operations you can find in CNC turning. So you have a basic outline of CNC turning operations. Let's also look at basic operations you can find in milling. Also in milling you have these facing operations. You can find what you call 2D facing operation, creating a flat surface, or we are flattening the surface or moving some material to create a flat surface on top of our workpiece. You can have also 2D contour, normally for cutting outer profiles. Like you want to create plates, brackets, or enclosures, you can use what you call 2D contour, where the 2D can use end mill or even facing if it is required for that operation. You can also do what you call slot milling. You can do pocket milling, that is 2D, two-dimensional. You can do rough pocketing. You can do what you call rest machining. You can do boss machining. You can do 3D eye machining, 3D HSR, that is called high-speed roughing, 3D HSM, high-speed machining, and also what you call 3D HSS, high-speed steel machining. So it may depend on what you want to achieve. Those are some of the operations you can find in CNC milling. Okay, let's look at another aspect like approach, tool approach. As I said, for turning operation, tool approach may approach for a safe distance. You can also ensure that you have a safety distance. Like an example, in this case, you see this is a safety part. Let me use an example. What example? Let me use this example. If you look at this example, as I said yesterday, we have what we call three parts of a program. A program consists of tool approach, cutting body, and tool retraction or safety retraction. So this is the approach. So because it has now where you are positioning the tool, they are not cutting, it's what's called approach. So you need to understand how you approach the tool from a safe point. You see the safe point here, they have put a safe point of Z2. So it's away by 18, then by 12, by 2, because they are going to do a thread on diameter 14. Okay. So you need to also understand how to adjust parameters to avoid insert being a shock. Like example, approaching gradually, or use the right coolant so that you prevent the insert from being affected. Or these are some of the things you understand that when approaching the turning. The same way applies to milling. Either you're using climb milling or down climbing. Down milling, you need to understand how you're going to approach, either using what you call ramp, helix, or planching. You can either approach using ramp, helix, or planching. Then normally when you're doing most of the using end mills, avoid using ramping, planching, because end mill have sharp edges, so a sharp flat edge. If you apply or you approach using planch, then you are just breaking the material. You can also use what you call high-speed machining, HSM strategies, or a trachoidal approach, or you can use step over with small step down to avoid tool breaking. Then lastly, programming. You can either approach your programming way through either manual programming or computer aided manufacturing. Computer aided manufacturing is just a CAM software that helps you to automate your programming. The common one that are used in most of the industries is what we call Mastercam. You can also use either Siemens NX CAM. You can use Autodesk Fusion 360. you can use SolidCAM. It has the power of doing mold work, dies, and also injection molds. You can use what we call top SolidCAM. You can use Esprit CAM. You can use Hyper Mill. You can use Fusion 360. You can use SolidWorks plus SolidCAM, because now SolidWorks has its own SolidCAM. You can use Mastercam suite. You can use a free CAD plus a pad workbench, and you can use trained for the purposes of simulation. This can also allow you to do simulation. So understand each one of them, how you're going to relate with your operations. Then this lastly is on I have done a research on comparison. Some of the operations that you may find, for example, for CNC turning, you may find normally the name is called facing, but when you go to Mastercam, it's called face. When you go to SolidCAM, it's called facing. When you go maybe to Inventor CAM, it's called facing. So don't worry with them, as long as you understand how to program. The name may be different, but meaning the same thing. Then when you're doing OD turning or straight turning, it may come to Mastercam as OD rough and OD finish, but in SolidCAM it may be rough turning and finish turning. In Inventor CAM it may be turning or rough turning and finish turning. If you're doing shoulder or step turning, in Mastercam you can call it profile turning, but in SolidCAM you can normally call it just turning. The same name, they are almost called the same name. Then if you go to, let's say you're doing contour turning or profile turning, in Mastercam you call it contour turning. In SolidCAM you call it profile turning. In Inventor CAM you call it profile turning. Then for grooving, it just across all of them as the same, but you find in Inventor CAM they can either call it grooving or cut-off groove. So you need to understand the names, how to relate. So in case you are using a software for the purpose of making something that maybe you have never used it before, but you know how to use the software, don't worry, you can just maneuver. These are some of the names you can find. Thread cutting, maybe you can find it in Mastercam called threading. In SolidCAM you can call it thread turning. In Inventor CAM you call it thread turning. So these are some of the names. I've just put a summary so that you're able to understand or maneuver around each one of them, so that you don't affect giving the output. Like pocket milling, you may find Mastercam called pocket. In other softwares like SolidCAM you can call it pocket milling, and maybe in Inventor CAM you call it 2D pocket. So it depends on how the names have been put, so that don't fear, but you refer to the correct name. As long as you know how to program with one software, it is easier to maneuver to another software, because some of these parameters may be the same across when you're doing machining. For example, in Mastercam, if I were to call what to call morph or parallel machining, in SolidCAM you may find it being called 3D parallel finishing, but in Inventor CAM also they call it 3D parallel finishing. So the names may be different, but understand how they are used across, so that you're able to write the right program. Also, check on the key terminologies for each of the softwares, maybe for the easier of allowing you to maneuver across different softwares for the purpose of giving the output as it is required. So this is just a guideline for you to understand, so that when you are programming, key parameters are very important. As I explained yesterday, some of the key parameters you need to be checking across when you're programming. They are very relevant in your field, so that when you're programming something, you understand what is necessary, understand how you're going to troubleshoot. At the end of the day, you're able to create a program that's relevant for industry. Thank you.